Okay, this is going to be a video about torque and power in car engines. So we'll start off with Newton. The acceleration of the car is the net force on the car divided by the mass. And we can divide this net force into two parts. We've got the force of the tires on the ground, and then we've got friction forces. And the engine is going to have a characteristic curve called the torque curve that gives us the torque for any particular engine speed, omega. So the force of the tires is going to be this torque divided by the tire radius, and then the friction forces are going to be mostly air friction, so that's going to be some constant that you could look up online for your car, multiplied by the velocity squared. Now, there's a relationship between the velocity of the car and the engine speed. Velocity is just engine speed times the radius of the wheels. So we can rewrite our force term now as torque as a function of car velocity divided by radius, and all of that is divided by radius. So at some point you've probably heard that there are different types of engines that are good for acceleration or good for towing, and others that are good for maximum speed. And I want to point out that all of these three situations can be described by the same equation. So this is the only equation you need. So if you're towing something, you just put a bigger mass here. And for maximum speed, you start out at 0 and you accelerate until you can't accelerate anymore, and then that's your maximum speed. So this is the only equation you need for all of those situations. So to be easy to start out with, we're just going to connect our engine directly to the wheels, and we're going to set our wheel size equal to 1. And we're also going to ignore the mass of the car and the friction. We're just going to look at the force. When you're designing your car, you want low air friction and low mass, but that's a separate thing from the engine design, so we're just going to leave that part out for now. So this is our torque curve for our engine, and because we have set our wheel radius equal to 1, we've got our velocity and engine speed are the same, and we've also got our force of the tires on the road is the same as the engine torque. But now we're going to change the size of the tires, and then these two functions will no longer be the same thing. So first thing we're going to do, we're going to try to make the tires half as big and see what happens. So this is our force equation. If we put in a 1/2 here, this 1/2 in the denominator, that makes our green curve twice as high, and the 1/2 in the argument here contracts us horizontally by a factor of 1/2. So this red curve is our engine torque. It's also our force versus car velocity when we have the size 1 wheels. But when we have our size 1/2 wheels, now our force is this green curve. And we could also have a set of tires that's twice as big. That would be this blue curve. So now we're driving our car. We want to accelerate from 0. We start at 0. So we put on our small wheels. We accelerate along this curve, this green curve with this force, until we get to the intersection here. And then we switch to our regular size red tires. And then at this point, we switch to our big tires, our blue tires. And we're maximizing our acceleration, through all of these velocities. And our goal here is we want to maximize the force on the road. We're not maximizing the torque. These are force curves. These are not torque curves. And I can plot the torque curves and the force curves on the same velocity scale. You see the torque curves here on the bottom. These are all the same height. They're just stretched out. So, and the shift points are going to be different between these two cases. So if we look at where the green and the red intersect in torque, if we shifted tires there, you see we're shifting too soon. We would rather have the green tires for a longer amount of time and then switch here at a higher velocity. So instead of having three sets of tires, what if you had an infinite number of different tire sizes? So here I've got an infinite number. The blue things here are just the red curve contracted and shifted, not shifted, but expanded upwards by a factor of 2. So you can see there's a force curve there, and then there's a really flat force curve here also. And so at any particular velocity, we want as much force as possible on the road. So what we want to do, we want to go along this edge here, along this blue edge at all times. And that's how we get our maximum acceleration. And if you look at how these curves are being copied, really what you're doing is you've got this yellow point here on your torque curve, and as you make the copies with the different scalings, you're just copying this yellow point, and this yellow point is what's going along this edge here. So you're always wanting to operate your car at this yellow point, and these other points here, these really don't even get used at all, because you're always switching your tire size, or you're switching your gears so that you're at this yellow point. Now, this is kind of a convoluted way of calculating your ideal operating point. We've got an infinite number of curves, and we're finding some kind of tangent to them. It would be nice if we had some mathematical function that would give us this yellow point directly. So we go back to our equations. Our force here was torque divided by radius, and we're going to be choosing the ideal radius at any given time. So we're just going to substitute this radius out and assume that we can shift that however we want. So this is our equation relating speed, radius, and velocity. And we substitute in, and now our acceleration looks like this. This is our force, omega, times the torque divided by the velocity. Now, at any given time when you're driving your car, you're going to be at some particular velocity that you can't change. You have to accelerate away from that velocity. So whatever your velocity is, you can't change that. And all you can really change is your engine speed and your tire radius. So what we're wanting to do, we want to maximize this engine speed times torque at any time to get maximum acceleration. And engine speed times torque has a name already. That's what the power of your engine is. So we wanted to figure out what this yellow dot was that's being translated along this blue edge. And what that is, that yellow dot is the point of maximum power. So if we have a particular torque curve, we multiply that by the engine speed to get our power curve, and then maximum acceleration is operating the engine at the maximum power at all times. And that's it.